Hi guys, welcome again to Simplified RSA, the guys who makes it looks easy. At this point now, I dream of a day where I don't have to introduce myself, but for now, I'm Mr. My Money. And on today's video, okay, today we are deviating a bit to the topic called statistics. Reason being, one student asked me to do this question. As usual, here is the question we have. Now, here is something interesting about statistics. There was a point in time where during my curriculum, let me just put it out there. This is gonna actually expose how much of a fossil I am. So there was a time where statistics was not included in high school curriculum. Personally, myself, I started to know about statistics as a module when I get to a university institution. And most students that I assist, they are from UNISA. There's a module from UNISA called Basic Statistics. The code is STA 1510. That module, how do I say this? I don't know for now that they've introduced statistics in high school, but then during our time, again, exposing myself as a fossil, way back then, a lot of people would find the module challenging, and if you're a tutor, you would make more money through STA 1510. Those who know, they know. And a question like this reminds me of a subject like that. But then here is the funny thing about the whole STA 1510. It was a statistic module that came in a form of a multiple choice. So you're writing an exam. The exam is out of 25 questions. All the questions given, they are in the form of multiple choice. Hence, I say, this reminds me of that. I probably think the student who sent this is probably a UNISA student. I'm not sure. I'm just assuming. From the 25 questions, it's like there's no questions that is better than the other in terms of marks. If you answer the entire 25 questions and you get 25 questions correct, and then you get your 100%. If you get 13% correct, and then you know, like, you need 12.5 to get 50%, and then you'll get your 55 nyana there, of which I always found humor out of it, because here you are writing statistics about probabilities, and yet there's a probability that you might get a certain mark even if you know nothing. I don't know if you get what I'm saying. You are writing a statistics exam about probabilities and you don't know what you're doing. Somehow, students could pass STA 1510 even if they don't know what they were doing, because you're just guessing. So they give you a question, they give you 5 or 4 options, just like this case here, and then you select the correct answer. But I don't know. I'm just sharing the story. I'm sharing the story because I want high school students to understand that basic statistics that is done at UNISA is the same stats that they are doing in high school in the form of an introduction, because there was a point where there was no statistics in high school curriculum. So a grade 11 students who understand stats properly, or a grade 12 students who understands the section of statistics properly, there's a high chance they can assist their mother who registered HR at UNISA while they're now working because they needed a promotion of some sort, but then they had to finish this qualification. And then you find that now stats becomes a problem. And then now we have questions like this. So if this was given in a university level, a high school student can assist to answer this. But then for now, let's do this together, because anyway, I'm the guy who makes it looks easy. So I have to make this one looks easy for now. Let's do this. So the question is straightforward. If event A and B are independent, probability of A is 0.4, probability of B is 0.30, and then they want us to determine which of the following statement is incorrect. I'm going to list all the statements here as they are, but without the answers. So here on the question, they've given us all the values for these, but then they want us to tell which one is incorrect. To approach a question like this, yes, personally, I do understand this is a statistics topic. And yes, I do know the chapter is probabilities. Of course, yes, I do know that there is a probability that you might guess the answer and get it right, even if you don't know what's going on, because it's a multiple choice in this case. Probability this, probability that. But basically, what this question is about is actually the application of conditional probability as well as probability of events. I did a video in the past. If you look on our playlist, you're going to find a video that says conditional events. I mean, probability of events. If, yeah, you can, if you don't understand what's going on here, you can just go back and then watch that video and then we'll take it from there. But then otherwise, hear me out. Here, what we're going to do is we're going to calculate each one of these, hoping to find the correct answer. So now we're going to answer. Okay, based on option 1 to the final option, we're just going to calculate each one of these. And then we're going to determine which one is incorrect from this after calculating everything, because we are not guessing. We are not using probabilities to guess. We are using probability applications to actually find the correct answer. So let's see how it's done. So from the given information, probability of A is equals to 0.40 and probability of B is equals to 0.30, like that. And they say A and B are independent. They say A and B are independent. This is what we have. Obviously, the word independent is a key to something special, but then we're going to talk about it when we get there. Let's answer this 1-1. Now, let's start with the first one. Probability of complement of A. Probability of complement of A. Now, complement is the opposite of the actual results. Probability of A plus probability of complement of A must always give us 1. This is a rule according to stats. Probability of A plus probability of complement of A must always give us 1. Here's an example. If you write an exam, you get 40%. It means you passed the exam 40%, but then you failed 60% of the exam for you to get 100%. You are writing an exam, you get 40% successfully. That's your mark. It means you failed 60% for you to could have gotten 100%. That's what the complement said. So the positive one plus the negative one must always yield 100%. And we know that the sum of all probabilities anyway, the sum of all probabilities is always equals to 1. But we're going to emphasize on that because for now we just want to answer the question. So in this case, it means if the probability of A plus the probability of complement of A is equals to 1, it means the probability of complement of A is going to be 1 minus the probability of A. Because from here to get the complement, we just take the probability of A to the other side of the equal sign. And then since it was a positive, it's going to change the sign and becomes a negative. So from here, solving for P complement here of A is equals to that. And then already I know this is going to be 1 minus 0.40, whereby I get 0.60. That's the complement of A. Let's not look at the solutions yet. Let's just get our calculations first. So the complement of A, we get 0.60. Personally, this is my advice to anyone writing either, even if it's not statistics, as long as it's mathematics in a form of multiple choice. Forget the options that they give you on which one is wrong, which one is right. Solve the question itself. The answer itself will determine which option is right, which one is wrong. So now, hence I'm like, let's calculate everything. And then from calculating everything, we can tell which one is right, which one is wrong. Sharp. Let's continue. Independent means that the probability of A and the probability of B, we are answering number 2 now. Independent means that the probability of A plus the probability of B can be achieved just by multiplying the probability of A with the probability of B. This only applies when they say A and B are independent. If not, you don't use this equation. For cases where the word independent was not mentioned, we're not going to use this formula to calculate the probability of A and B. We're going to use this one. Probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. And then this is how you were going to get the probability of A and B, because somehow you would have been given probability of A and B, which you have. Somehow you were supposed to get the probability of A or B in order to get the probability of A and B. This was if it was not mentioned that A and B are independent. But because now they did say that A and B are independent, this formula applies for independency. This is the formula for independent events. So in this case, we're just going to go straight and say the probability of A is 0.40 multiplied by the probability of B is 0.30. 0.40 multiplied by 0.30 is 0.12. So meaning probability of A and B is going to be 0.12. Because the events are said to be independent, we calculate it like that. The probability of A, given that B occurs as well, these are conditional probabilities. The probability of A in condition to B is equals to, the formula states that this is the same as the probability of A and B. Don't stress, because these formulas are given on your formula sheet most of the times. So the probability of A in condition to B is equal to the probability of A and B all over the probability of B. So the way you arrange this is the probability of A and B is given by, even if they didn't give you the formula, you must just know that this is the same as the probability of A and B divided by the probability of the one in front, the probability of the condition. So it's the probability of A in condition to B is equals to the probability of A and B over the probability of B, which is the condition. So that's how it's done. You will see when we do number 5 that how does it look in terms of the opposite. So this is going to be, we already calculated the probability of A and B, it was 0.12, and then we divide by the probability of B is given to be 0.3. 0.30. Therefore, this is going to be our probability of A in condition to B. The probability of A in condition to B is 0.40. So I'm going to put it there. We have 0.40. We're getting there now. You see, now they want the probability of A or B. I did put out the formula again of conditional probabilities. Let me just rewrite it again. So number 4, the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A. This formula is normally given on the formula sheet, and we just substitute. So we're looking for the probability of A or B. We already have the probability of A, we already have the probability of B, we have this value, and we calculated the probability of A and B from the independency there. So just substituting, we're going to have 0.4 for A plus 0.3 for B minus 0.12. Whatever we get here is our probability of A or B. Using our calculator, the answer will be, this gives us 0.58. Therefore, the probability of A or B is going to be 0.58. This is the correct one. Now, finally, number 5, we are calculating the conditional probability of B in condition to A. Again, this is how you derive the formula, even if you were not given the formula. For number 5, we're going to say probability of B in condition to A is equals to probability. I can say probability of B and A is the same as the probability of A and B. I mean, I can write this like this, probability of B and A. So you can understand the order, because the denominator is going to be the one in front. But the notation doesn't even matter, because it's the same thing. So I can say probability of A and B but divided by the numerator is the one in front. So divided by the probability of A this time around, because we are looking for the probability of B in condition to A. So the event in front, you divide by its probability all the time, just like on the one for the probability of B and A, it was B in the bottom, like that. So that's what I wanted to explain first. Therefore, same story, we know our probability of A and B is 0.12 divided by the probability of A is 0.30. Therefore, no, divided by a probability of A is 0.40, not 0.30. Therefore, 0.12 divided by 0.40 is equals to 0.30. Therefore, the answer is 0.30. So we've gotten all the values that we have in terms of this, the correct ones. So looking at our options, we can tell, according to the options, they got this one correct. We got the same one as this. We got the same one here. We got the same one here, but probability of B in condition to A, they got 0.40 and the actual answer is supposed to be 0.30, meaning the incorrect answer is option 5, which is the correct answer according to the question, because they wanted us to point out the incorrect answer. So all the 4 is correct, but this is the incorrect one. This is how you answer a question like this. Guys, this question is tricky because normally when you answer your questions, you are used to the point that in multiple choice questions, you are always given to show the correct answer. Here they gave us 5 options. 4 are correct. They want you to show the incorrect one. If you are in a hurry, you are panicking, you are thinking of a lot of things, you're going to calculate the first one, you think it's correct, and then you feel like because you want to save time, you don't necessarily have to prove the other ones, and then you circle option number 1 because it's the correct answer. Indeed, the complement of A is 0.6. Only to find that they never wanted you to show the right answer. No. The second one, had you tried it, it was going to be correct as well. So is the third one, so is the fourth one. But then they wanted you to calculate the incorrect answer. That's the whole trick about statistics. Like I say, it's humorous you can write stats under multiple choice while the question is about probability. I just find that funny anyway. But that's not the point. I just wanted us to answer this, but now we're good. I think we get the idea. But then I'll do more theoretical related questions based on this. For today, this was on the table. I'm Mr. My Money. This is simplified RSA because it makes it look easy. Please remember to subscribe on our YouTube, guys. Subscribe on our YouTube page, follow us on Facebook, follow us on TikTok, Instagram, and most importantly, now you can access our learning channel through Spotify. You just go to Spotify if you have the app and search for learning channel. You will see that logo, black and white with that simplified RSA thingy. And or otherwise you can just search for simplified_RSA on Spotify.